So good afternoon, everyone. Welcome. My name is Marco Ducci. I'm the CEO of Euro USC Italia, consulting based in Italy, supporting operators and manufacturers on US regulatory aspects. So I'm really honored to be here today to moderate this great panel about EU regulations for docked drone operations. We all know that BVLOS operations have the potential to transform industries from infrastructure inspections to logistics, for example. However, turning this potential into reality requires more than just technological advancement. And the real challenge lies often in navigating the regulatory framework, ensuring safety compliance, and of course, securing the necessary approvals. So that's why today we brought together an exceptional group of experts to share their insights on how to set up a remote command center for BVLOS operation. And we'll discuss key topics with them, like selecting the right hardware and software, of course, but also integrating critical safety components and, most importantly, getting approval for the operations. So I'm really honored to be joined here by a great team of experts. They bring a wealth of knowledge, hands-on experience in BVLOS operations, and I'm really excited to dive into this discussion with them. So let's get started, and let me give the floor to our panelists so they can introduce themselves. And I'd like to start with Irving from DJI.
Yeah, sure. Thank you, Marco. Hi, everyone. My name is Irving. I'm Dock Solutions Engineer from DJI Enterprise. Basically, I know our product, DJI Dock, and also we are cooperating with all the European dock market participants, I would say that, and supporting all the key projects in the dock sectors. And I'm very happy to join this session.
Thank you, Irving. So next in our lineup, it's Björn from Skydrone.
Hi, everyone. My name is Bjorn. I'm head of projects at Skydrone. We're a company active as a future use space service provider, counter UAV, and BVLOS drone operations in Belgium.
Thank you, Björn. And next we have Ludovic from Dronavia. Welcome, Ludovic.
Hello. Hi, everyone. I'm Ludovic, CEO of Dronavia. Dronavia is a well-known company. We provide flight termination system for mainly DJI drones, but not only, and also parachute solutions that help customer get SORA approval or C5 at the moment compliance for the DJI drones. And we also make remote identification devices. Thank you.
Thank you, Ludovic. And last but not least, Nicola from Aviu Group.
Hi all, I'm Nicola Marietti, CEO of Aviu Group. Aviu Group is an Italian company that helps the enterprise company in the introduction of a managed system in the operational and maintenance process. So we help a lot of companies in the BVLOS project, and we will talk later about that.
All right, thank you all for being here today. I think it's time to start diving into the topic of our discussion. And I'd like to start from Irving. So the first question I have for you is about your experience, because as DJI, you have definitely a vast customer base. So I'd like to understand from you what are the main challenges that your customers encounter when it comes to implementing docked drone solutions in EASA countries. So what's your experience on this?
Yeah, thank you, Marco. Yeah, thanks for the question. Basically, that's a question I always receive also from my manager in DJI. So what stops us to sell the dock? I would say that there are actually two key points. The first one is really complicated for a Chinese company to understand the EASA laws, like the regulations, all the drone regulation. It's really complicated to have those communication between us as a drone manufacturer and directly with a National Aviation Authority. Also to understand how the regulation works and how we can help our dock operator to achieve the regulated way to operate dock. It's a big challenge for us. And what's more, we're also having I would say market education. Dock is complicated solutions. We need to basically show customer how to plan a mission, how to launch the mission, how to analyze the data. It's also complicated for us, and we are working on both of the sides. And I think today it's really great chance to gather very a lot of important people to discuss about our first pain points. It will be really great and valuable chance for us to learn as well. Yeah.
Thank you, Irving. So I'd like to move to Björn with a kind of more specific question, because I mean, in my experience, at least, one of the key issues that operators have in general, but with docked drones operations in particular, is accessing the airspace. So we know that enabling seamless airspace access is definitely crucial for the scalability of highly automated operations. And in Europe, we often see that authorities are using airspace segregation as the go-to approach. But we can all understand that this is not really a sustainable long-term solution. So what are, in your opinion, the key enablers that are needed to integrate docked drones into a shared airspace effectively, let me say?
Right, Marco, as you mentioned, is not a scalable solution. So it's limiting airspace availability, operational flexibility, and so on. Our local CAA basically has decided that for a quick one-off POC, it's still okay, but for operational use, it's definitely not viable. So the problem with segregating is basically trying to solve the see and avoid that we're missing with drones by just eliminating the fact that there is something there that to see and to avoid. And instead of that, we developed a BVLOS enablement framework, which basically does a shift from see and avoid to detect and deconflict. And that BVLOS framework allowed us to operate different BVLOS flights from a centralized control center. One example of where we employed this framework is the Port of Antwerp. For those of you who know Belgium a bit, it's in the north part of the Flemish region. It's one of the biggest financial economical hubs in Belgium, and it's a really complex and challenging airspace with a lot of overlapping geozones like the International Airport of Antwerp, regional airfields, heliports, restricted areas, you name it. Everything you can find in the air is there. So basically, to be able to deal with that situation there, we would ideally be looking at U-Space there, which is one of the things that we're looking at today in a CESAR project called Birdie, where we're trying to establish U-Space and among other zones in the Port of Antwerp by the end of this year. But it's still not there, U-Space, and although it's a key enabler for this type of integration, we still had to deal with the fact that we didn't have it yet. So under the DHive project, we utilize BVLOS enablement, which basically takes strategic deconfliction via flight authorization services, real-time tracking through network identification and surveillance equipment, tactical collision avoidance using the traffic information services that we as Skydrone provide, and a UTM system based in a geozone with its own access conditions for crewed and uncrewed aviation. So in a nutshell, basically that framework, and if you are a bit familiar with SORA, it's basically based around common structures and rules. We are able to mitigate the air risk down to a SAIL2 and allow for a safe and sustainable mission in that type of area.
Okay, yeah, that's very interesting, and it looks like a promising solution, because we know that U-Space regulation is there in Europe, but U-Space in practice is not yet fully implemented anywhere. So we need probably some kind of shorter term solutions to get BVLOS operations going faster. Okay, thank you very much. So let me move to Ludovic with a question that is more about specific functionalities that are often needed. So we often see that to obtain an operational authorization for a drone-in-a-box solution, it's needed to integrate additional safety functionalities which are not always coming directly with the drone-in-a-box solution itself. So in your experience, what are the most common requirements that are imposed by regulators in Europe? And do you think that technology is mature enough to meet these demands?
Yes. Yeah, obviously, most of the drone in the dock solution don't implement all the necessary feature to get easy flight authorization. And that's where Dronavia is entering in place, because we provide flight termination system, and it's the key thing, the flight termination system in the regulation. It's an old concept, but still in place, and regulators want you to be able to kill the drone if needed, if you lose control. And we have flight termination system at the moment for most of DJI drones, but it's kind of line of sight flight termination system. You are on the same site as a pilot, you are on the same site of the drone, and you are able to stop the flight with a dedicated remote controller. That's the basic flight termination system. For dock solutions, where you have no pilot on the ground, you need additional feature. You need to have the capability to trigger the flight termination system through internet, and it must be in a way independent from the platform you'll use for setting or piloting the drone itself. Or you can also add some geocaching feature on the drone, meaning the FTS will be able to rely on a geocaching solution, but a different geocaching than the one implemented in the drone. So the main two features to get flight authorization at the moment, flight termination system and geocaching solution, which means you need to add this to actual DJI drones or other drones, because most of the Chinese manufacturers, they don't have all those solution integrated in the drone at the moment. In many other countries or markets, it's not mandatory. It's really a European specialty. Is it mature? At the moment, flight termination system, yes, they are really mature. And we are working hard on the ability to trigger flight termination system through a new platform like Flight Hub or FleetBase. And we are working hard on geocaching solution too. It will be available this year, hopefully first semester. And this will really unlock the usage of the drone, because if you don't have those two possibilities, remote triggering of the flight termination system or automatic triggering through geocaching solution, it's really complex to get flight authorization. You need somebody on the ground, and you lose all the interest you have with drone in a box solution, which is full remote control of those solutions.
Yeah, thank you. I mean, this seems to be currently one of the main challenges. So increasing the level of autonomy of operations with docked drones. So let me ask to Nicola, who is representing an operator, his perspective on this. So Nicola, you are a system integrator and soon to be LUC operator. So how do you see the role of these docked drone solutions evolving in the near future? And do you believe, based also on what we discussed until now, that full autonomy is feasible in the short, medium term?
Good question. Really, really good question. Of course, we are in very, very close to the business needs as a system integrator. So we perfectly understand that the use of docked drone from customer means in the mind of the customer that they want to pay less for the flight of the drone themselves. So autonomous it's important for them, but I think that we are not so close for having full autonomous flights. I try to give you some of my idea for letting drone really autonomous. I think that artificial intelligence in general needs to be improved in terms of letting the drones collaborating with other drones and other systems in real time for the safety of the flight, of the safety of the environment. Second point for the fully autonomous flight for me is something that is not ready now. And so the ability for the drone to self-maintenance themselves. today we have drones that are in a dock, in a nest. They can charge, they can exchange data between the platform and so on. But we need the human intervention for the maintenance. For a fully autonomous process, more than drone, we need that also the drone or also the nest can have some feature of self-maintenance, and this is something that do not exist yet. We talked, and the other colleague talked about the needs of the U-Space UTM for managing the collaboration in the air drone, and I totally agree. Last things for me is the reliability of the sensor and of the communication into the drone. Like the airplane, we need drone that are able to have more redundancy of the system, so the file safe, the parachute is okay, but also in the communication system and the flight control and so on. I think that more reliability on that and more redundancy, it's important for having at the end a fully autonomous services.
All right, thank you very much. I think it was a kind of interesting first round of answers. We already raised some of the critical points that we have now in this domain and the key issues that manufacturers and operators are facing when it comes to getting approvals for docked drones operations. So now I'd like to kind of dig a little bit more into some detail of some of the challenges that are often encountered by operators and manufacturers. And I'd like to start from Ludovic. So ground risk mitigation is one of the key things to be addressed, especially when operating in areas where there might be people, so sparsely or populated areas. And the solution that is often used is that of parachutes. But we all know that parachutes are not effective if the operational height is below 40 or 30 meters, something around this value. So how do you see the regulatory requirements evolving in this regard? So how do you see the possibilities of mitigating ground risk by operating at very low level, possibly without a parachute?
Yes, it's a good question. Actually, the regulation, it don't explicitly say you need a parachute. You need a way to reduce the impact energy in case of a fall. But technically speaking, parachute is the most easiest way. Let's say that because it's lightweight, it's reliable. Meaning, of course, you need at least 30 meters to fully deploy the parachute and slow down the speed of the drone. But it's reliable and it's a well-known technology and it's lightweight. It's mainly the key point because actually, technically speaking, you can put almost everything on a drone, but it must be lightweight. If you put a big accessory, heavy accessory, you lose lots of benefit. Autonomy of the drone, flight duration, and also controllability of the drone. And that's why I think most of the accessory manufacturers make parachute system because airbags are heavier and other solutions are more complex. But in the other hand, you extend, of course, the buffer zone because when you have a parachute and when you have wind, you have a lot of drift of the drone. So it's not the perfect solution at the moment, the parachute in populated area. The regulation, I think, will go in different way. First, for the C5, which is not a scenario for the dock solution, but in C5, it's highly probable that the parachute will not be mandatory anymore because it's not crossing all the box for the populated area flight. Buffer too big and the solution works up to 30 meters, and most of the missions are below this level of 30 meters. So either we can think parachute or other way to reduce impact energy will not be mandatory anymore, because considering you are in a segregated area, or either we need to find other solution to reduce the impact energy. That's for C5. For DOC solutions, for BVLOS flights, it still makes sense for operations at high altitude, or when you fly over populated area with high density. Parachute still makes sense because it's been perhaps 8 years we made parachute systems. Those systems are reliable, and it's a good solution at high altitude. But clearly at low altitude, below 30 meters, we need to find other solution, regulatory ones, or technically speaking, other solutions at the moment.
Okay, thanks. Yes, this is an interesting discussion because if you look at how the regulatory framework is built at the moment, I'm referring to SORA in particular, in order to operate over populated areas, you only have two options. So either you install some kind of system like a parachute or something equivalent to that, or you demonstrate a high reliability of your system as a whole, which might be, again, challenging and expensive to be done. And I'm not saying that current technologies are not reliable. I'm only saying that it might be expensive to demonstrate a given level of reliability, which is a different story, actually. Okay, so thanks a lot. I'd like now to move back to Nicola with another question about operations. So the main benefit of operating docked drones is that you can operate from a single location, like a remote control center, fleets of docked drones distributed along a wide area. But this is, of course, coming with significant logistical and regulatory challenges, like the need of having a generic authorization or an LUC, for example. So in your experience, in your view, what are the key operational strategies that organizations should adopt to streamline approvals, make it quick, and ensure compliance?
Okay. It's not so simple to answer, but I will try with some example on ourselves at the hand. We started remote operation activities 2 years ago at the end, and we started with specific and experimental authorization by our national authority. So we started with the NOTAM, we started with the segregation of the area, and so on. We are talking about project related to the highways. So we installed Nest on the highway for different uses, traffic monitor, infrastructure, inspection, and so on. At the end, for letting the customer, or in general, expanding the usage of the drone, we moved to the LUC certification. So the answer is to create a control center with a LUC certification, and that's what we did last month with the closing of the LUC process, because what we were doing in experimental phase was exactly what the LUC requests at the end. So have a safety management procedure, have a proactive regulatory engagement, checking every time if something changed in the rules of inside our project. Have a compliance officer at the end who check every time the changes and so on. So mainly my answer is if you want to scale, if you want to adopt this kind of technology, you need to have an LUC certification. Then, because the logistics is important, we have different nests around our country. Of course, a standardization of the technology is it's important at the same time. So do not have many vendors, do not have many options, many platforms, and so on, but choose the best one in that moment and take it and use it. This is the simplification of the fleet management and the simplification of the operation. That's my answer for having under our hand the management of the compliance and the management of the logistics.
Yeah, thanks. I mean, this is, I think, great input. So LUC was intended exactly as the tool to enable more complex and more advanced operations. So using LUC for this kind of activities is exactly the perfect solution. I agree. And let's hope that industry will go in this direction, because this is going to be a win-win for both operators and regulators, reducing their involvement in the approvals. Okay, so let me now move to Björn, and I'd like to go back to the discussion about integration in the airspace. We mentioned before that we do have a regulatory framework in Europe about U-Space, which is exactly designed to support this drone integration. But we also see that U-Space airspace implementation is still in progress almost everywhere. So in the meantime, right now, like if you were to start your operations tomorrow, what kind of technologies can operators use to mitigate a risk effectively? So before you talked about procedures, but are there specific technologies that you would recommend?
Yeah, indeed. So as I mentioned in the previous question, the BVLOS framework relies basically on the same type of services that U-Space would impose to the U-Space service provider to provide to operators. So the flight authorization service, real-time traffic information, all that kind of thing that is known very well by everybody in this panel. In U-Space, we're basically putting that towards operators as services in there. Now, key necessities in that setup are, for one, the electronic e-conspicuity. The main issue that we see today with at least the air risk is the fact that CMBC is a necessity, especially for BVLOS flights, and their existing technologies are usable if you combine enough and the right data sources. So what we do in Belgium is we combine for man deviation ADS-B, FLARM, Mode S, and then Mode S in combination with MLAT, or Mode S in combination with the approach radars of our national ANSP. In terms of detecting cooperative drones, we have telemetry API that allows for the operators to provide their telemetry directly to our system, and we can redistribute it to other customers. So different drone operators, for instance, in the port of Antwerp, can see each other fly to deconflict. Next to that, there's also the issue of non-cooperative airspace users, where basically, if you look at typical areas around the ports, around airports, where you should not be flying without a permit, 99% of the pilots or operators there are flying legally without knowing it, or willing with knowing the fact that they're flying illegally, but just don't care about it. They're also posing a threat. So in terms of key technology today, definitely any technology to provide you with a better situational awareness in the airspace is a must. There's no question about that. Other than that, it's mainly taking a look at the similar services that we will be getting in U-Space. So as I mentioned, the 4 mandatory services, where we're talking about flight authorization, real-time airspace awareness, network identification, and then tactical collision avoidance with a TIS based on that e-conspicuity. If you can already employ those and then combine that with the flight termination system, like Ludovico was mentioning, for instance, then you have a strong case of being able to actually fly today without U-Space. Does that mean that we don't need U-Space? Simple answer, no, because it's still limited in locations where you can actually employ this strategy or not.
Well, thank you. Thanks a lot for this answer, and I'd like to build on what you just said by asking something to Irving. So the regulatory framework is evolving. EASA is going to adopt the new SORA 2.5 in the coming months, which is going to solve some of the issues we discussed here about ground risk assessment and mitigations. But air risk will still remain a major challenge. So on your side as a US manufacturer, do you see any specific solution among those that Björn mentioned or others that could be integrated into your products to facilitate airspace access, mitigate the air risk in general?
Yeah, sure. That's actually a very critical question. We also receive many, let's say, product requests from our customer, like how your product could help us to like guarantee the airspace safety. It's really a challenging question. I could share something that we are start to work on as like emergency landing. If there's any like helicopter passing by or manned aircraft passing by, it's possible to land the dark drone. Okay, currently on FlyHub 2. Also, something what we already worked on is ADS-B. So we are all the time receiving the broadcasting ADS-B signals on the drone, and we have the onboard sensors on the drone itself. And I think in the future we are also very open to receive more and more requests and have more like better, but put it easily away for our dock operators. And on the other hand, we're also working on a more robust system. That's actually, let's say, our strength as a drone manufacturer for many years. We know about the UAV system. We know how we can improve the IP rating, the wind resistance, and all about the robustness, how safety we can even build more of the system. Yeah, basically that's the direction that we are working on next generation of the dock.
Well, thank you. That's good news, I think, for a lot of people out there. So I'd like now to pick some of the questions that we received from the audience. There's one that is kind of general, so I will split the question into two different answers. So the question is how to basically get an approval for a BVLOS operation with a dock drone from an operator and a manufacturer perspective. So I'd like to start with Nicola with the operator's perspective. So what would you say, Nicola, is the key to obtain an operation authorization with a dock drone? What is the most relevant thing that you need?
It depends, of course, of the use case of the mission of the operation, where the operation are, and normally as a service operator, we need to fight against the customer needs and the real world of flying drone. But by the way, the authorization it's a standard process at the end, because we need to create a CONOPS document. We need to make SORA. We need to reach the 72. So there are steps that are mandatory for the safety of the flight. And that's what we do. So we calculate all the parameters for letting the operation feasible at the end, working with the parameters that we can move to have the right value for the authorization at the end. Today, we cannot fly 400 kilometers in BVLOS from moving from one country to another country. But of course, but for sure, we helped all of our customers to achieve the request for BVLOS mission. at the end. We never fought for a standard or advanced request. It's a matter of balance between between technology, between operation.
I see. But I think you said a very important thing. So we designed the mission and the concept of operations to reach a maximum sale of 2. That's probably one of the limitations we have now, that operating at sale above 2, it's nowadays close to impossible, I would say, for many reasons. So let me now take the manufacturer perspective, Irving. So what is, in your opinion, the main driver to obtain an operational authorization at sale 2 and in the future potentially at sale 3 for exploring more possibilities?
Yeah, sure. So if the operation risk based on the risk assessment, if it falls under cell 2, like 1, 2, it requires a huge numbers of the documentation, I would say. It's a lot of like paperwork we need to do. It's so there are basically just 2 ways: done by yourself or done by the professional hands, like Marco team. So from DJI side, we are actually providing a template with all like the fulfilled specification of our product. So actually, the operators can use it to save your time to prepare for the documentation for the paperwork. But it's also recommended to put this, let's say, the huge work to a professional hand to like save your time, also like in a very sufficient way to get approval. And another topic regarding the operation, which the risk is, let's say, the falls into cells 3 and 4. I believe we are also working on several technology to ensure more robustness communication between the machine and human, like machine-human interaction, like use the machine technology to correct the human mistakes, like operators' mistakes, and some network insurance, and some like security of the internet. Yeah, we are working on it in different perspective. I believe it's soon in the future we can also reach some use case in the cell 3. Yeah.
Okay, thanks. Thanks a lot. I think we have a question for Ludovic. This is definitely for you. So there's a question about flight termination systems. So if you can explain a little bit more in detail how a flight termination system works and why it's so important for BVLOS operations. So why do we have this requirement in the regulation, and where it's coming from? I think you're muted.
Sorry. Yes. So flight termination system, basically, it's a system that enables the termination of the flight. So meaning, additionally to the feature included in the drone, the flight termination system is independent and has its own way to terminate the flight. The goal for in a regulation perspective is, if you lose the control of the drone, it's better to terminate the flight by stopping the motor somewhere you are. And it's better than letting the drone go somewhere you don't know, basically, because when you start your mission, you set the flight area, flight volume, and authority wants some guarantee that you will stay in this flight volume. And flight termination system is a way. There's other ways too. It's a way to guarantee that the drone will stay in the flight volume. Because if it leaves the flight volume, either you trigger the flight termination system and the drone is staying in the flight volume because you terminate the flight, or either a geocaching solution automatically trigger the flight termination system. And both ways, you ensure the drone is staying in the flight volume. That's really the reason. And it's some kind of an old regulation, because at the beginning of the drone market, you got some drone, even from DJI or big manufacturers, that encounter GPS malfunctions and make some flyaways. Now it's less and less the case, but there's still some scenarios when you can have a flyaway, and flight termination system is a way to eliminate the risk in case of flyaway.
All right, thanks. Thanks a lot. So we have another question. It's kind of specific, so I'll try with Björn. You tell me if you can answer this. So the question is if it's possible to, I guess, simplify the approval process to use one of the predefined risk assessments. In particular, the question here refers to PDRA G03 for drone-in-a-box solution operated below 30 meters above the ground over a spatial-rated area. So do you have any experience of using PDRAs for dog drones operations?
We've been looking at different PDRAs to enable this. And if you look at Golf 03, it's basically made for the use case described there. The main hurdle, I would say, is the fact that it also demands a direct C2 link. So depending on if you can basically get your CAA on board with the fact that you can guarantee that you have a direct C2 link at all times and not just a cloud link via FlightHub or FlightBase in this case, then it should be possible, because looking at the question's details, the maximum height is not over the limits of the PDRA. The dimensions of the drone, kinetic energy are all fine. So it's basically boiling down to that. Can you have them believe that it's a direct link, which is a basic discussion point?
Yeah, you're definitely right. So that's one of the main limitations, and I think these kind of limitations are also one of the reasons why PDRAs are not so much used in Europe until now, because in the end, doing your own SOAR analysis gives always much more flexibility in terms of how you can design your operation.
We use the exact same PDRA for one case where we were able to get the BCA on board to allow it. But we had to have a person in the field standing by with a remote control as a backup, which still doesn't make any sense in the commercial.
All right, so I think we are at the end of our discussion. We covered many topics from the operational to the technical side. And yeah, to me, it was a very interesting discussion. I hope it was the same for everybody that joined us today. So I'd like to thank the organizers, FleetBase, for inviting us and organizing this discussion, and also all the panelists, Nicola, Ludovic, Björn, and Irving. Thanks a lot for being here. You provided a really valuable contribution. And so that's all on our side, I guess. And I hope to see you again in the next events from FleetBase. So thank you, and enjoy the rest of the NestGen sessions. Goodbye.
Thank you all. Bye.
Thanks, Marco.
Thank you, guys.
Thank you, Marco.
Have a nice day. Bye-bye. Thank you, Marco.
Have a nice day.